Hello, welcome to a video on high availability web application architecture on AWS, presented by Amanda and Shun. We will share the key components and architecture of our AWS cloud project, guiding you through the configuration steps we did in AWS Management Console. For this project, we have selected two regions, Northern Virginia and Oregon. In each region, a virtualized private cloud is set up with two availability zones, each containing a public and a private subnet. The public subnets host front-end instances running a web app's HTML and JavaScript code, while the private subnets house backend instances using SQLite database. Connectivity of the private instances to the external internet is facilitated through the VPC's Internet Gateway, connecting to the net gateway in the public subnets. Additionally, we have established a bastion host in one of the public subnets in Northern Virginia region. VPC peering is implemented to enable connectivity between the two VPCs, and Route 53 translates a website's domain name into IP address and route traffic efficiently. Elastic load balancers evenly distribute the traffic to our EC2 instances across multiple availability zones, and latency-based routing ensures that users are directed to the nearest AWS region for an improved user experience.
To start off our project, first we have to pick two regions to set up our project. For us, we picked North Virginia and Oregon. Second, we need to create a VPC in each region. Each of the VPC will have two public subnets and two private subnets. Remember to give different IPv4 cinder block for the two VPCs. For us in North Virginia, we have chosen 10.0.0.0, and Oregon, we have chosen 10.3.0.0. And here are the steps to create the VPC. After setting up our VPC, we can verify them from the resource map. You should see 4 subnets, 3 route tables, and 1 internet gateway for now. Also, we are able to see the 4 subnets in the subnet tab. Next is the route table. Each VPC has 1 route table for the public subnets and 2 route tables for the private subnets. The route table for the private subnet includes entries for the local IPv4 cinder block, NAT, and peering connections. The route table for the public subnets includes entries for the local IPv4 cinder block, this IPv4 cinder block of another region, and an internet gateway. Please note that we added the peering connection to the route table after confirming that the peering connection status is active. Next is the internet gateway. Each VPC has 1 internet gateway with the status attached to the VPC, which enables the VPC's resource to connect to the public. This way we can have horizontal scalability and redundancy, facilitating communication between instances, VPC, and the internet. Next is the NAT gateway. Each VPC will have 2 NAT gateways. Each is assigned to a public subnet with a public connectivity type and a unique elastic IP allocation ID. This way, the resources with a VPC can access the public internet, and elastic IP addresses can ensure resources maintain a consistent public IP address even if it's stopped or restarted. For the network ACL, it will remain unchanged in both VPC. Next is VPC peering connections. We will initiate a VPC peering connection from the VPC in North Virginia to the VPC in Oregon. After configuration, we will need to go to the VPC in Oregon and accept the peering connections in order to establish a connection between both VPC. Next, we will need to have 3 security groups. The first one is the bastion host security group. We select SSH with anywhere IPv4 and default for the outbound. This way, we allow access from anywhere. The second security group we have to create is front-end security group. We select SSH with a source of a bastion host security group and HTTP with anywhere IPv4. And the outbound rule is default. This way, the bastion host can act as a firewall to provide more security, and anyone on the internet can access resources with front-end security group by HTTP. The last security group we have to create is the back-end security group. It has an inbound rule for SSH with bastion host security group and HTTP with the same region's IPv4 cinder block, and the outbound rule is default. Next, we will have to create two key pairs, one in each region, as key pairs are region specific. These key pairs serve the purpose of enhancing security by enabling secure authentication and access to EC2 instances with the corresponding private key. Additionally, they ensure data security and integrity across various AWS servers. Select key pair type EDD25519 and .pen extension. Before we create our bastion hosts in North Virginia, make sure to have a key pair and a bastion host security group. Remember to select the VPC in the region and the public subnet with enable auto assign public IP and select the IAM role.
Before creating load balancers, we created two target groups using target type instances, and we selected the VPC we created in the region. The first target group is for the application load balancer using HTTP on port 80, with the rest of the setting left as default. The second target group is for the network load balancer. It is using TCP on port 80, and we modified the health check path to /API/users, which is the route in the backend script used for retrieving data from the SQLite database. The next step is to create elastic load balancers. For the application load balancer, we selected internet facing as the scheme, the front-end security group we created, two public subnets from the VPC created for that specific region, and the target group we previously configured. For the network load balancer is really similar. It's Instead of selecting internet facing, we selected internal as the scheme, the backend security group we created, and two private subnets from the same VPC and the target group we set up. And we repeat the same steps for the other region. Next, we create new launch templates for the front end and back end. They are set up similarly to the Bastion host template using Ubuntu and T2 micro instances. However, we do not select subnets within the templates. Instead, we will choose them when configuring the auto-scaling group. The only differences between the front end and the Bastion host are we assign the front end security group in the front end template, and we also enable auto assigning public IP. And we include a bash script containing HTML, CSS, and JavaScript code in the template. And for the backend, we assign the backend security group, and we include a bash script containing Python, Flask code, and queries to create SQLite database. After creating the templates, we set up auto-scaling groups. For the front-end ASG, we selected the VPC of the region and its two public subnets. And for the backend ASG, we chose the same VPC and its two private subnets. Both ASGs were configured with a desired capacity of 2 instances, a minimum of 1, and a maximum of 3 for the group size. We also implemented tracking scaling policies for both front-end and back-end to automatically adjust instance counts based on average CPU utilization, maintaining the CPU usage around 50%. That is the goal. Additionally, a new instance typically will require around 300 seconds for it to become fully operational and ready to handle workloads. We also enabled health checks and CloudWatch. And these health checks and health watch will allow us to monitor the status and performance of our resources.
To SSH into Bastion host private and public instances, we will be using keychain to manage key pairs. First, copy the key pair files to your Ubuntu folder. Install keychain by running the following command. After it's installed, run keychain and evaluate the SSH agent. Next, add the key pair files and navigate to the folder where you saved them and run the following command for each key pair file. Then verify if the key pairs are added successfully. Now we can SSH into the Bastion host and other instances securely. This is the SSH into the Bastion host screenshot. From the Bastion host, we can SSH into one of the public front-end instances. This is the HTML file in the front-end instance. Our front-end script modified the Nginx configuration file. We can also curl the backend to retrieve data from the database from the front-end instance. This is the path we are fetching in our front-end script. Exit the front-end instance and SSH into one of the back-end instances. The back-end instance successfully executed the back-end script, which created an SQLite database file.
The final step of the project involves purchasing a domain name and creating the hosted zone and records in Route 53. A hosted zone is automatically created after purchasing the domain name. So we added a record with the subdomain ACIT 3640 and using record type A. And then we enable alias, which allow us to route traffic to application and classic load balancer, and we selected respective load balancers in each region. For the routing policy, we selected latency, which ensures the nearest AWS region will provide content to the users. And in this screenshot, you will see that two record types are created, and the latency is the routing policy. And it is routing traffic to the front-end load balancers in both regions. Hello, in this project, we selected two regions, Northern Virginia and Oregon. Our location is in Vancouver, BC, so the closest to us is Oregon. I'm going to show you that my website is working. So this is my subdomain, and this is the domain name that I purchased. And when I refresh, you can see the instances are changing. And when I fetch data, the button is working and it is retrieving data from my database in the private instances. And I'm just going to terminate all the front-end instances that are running in Oregon region. I'm going to show you that the website will display contents from US East instead of US West when the region Oregon is not working. So this is the front end and this one. So I currently have two front end instances and I'm going to terminate both of them. So as soon as I shut down the instances, it should stop working. And you can see that it is working in the East region. So the West region failed, but the East region was able to still display the content to us. And when I fetch data, it is still working. So now it's showing that it is in the West region again, and I am able to retrieve data. But when I refresh, I cannot see a different instance because only one is currently running.